Thanks for sharing your journey. It seems like throughout your career, you have worked a lot with kind of big data problem, distributed systems, microservices, and also like optimizing to the low level. You mentioned about building like connectors, drivers, and things like that. So obviously you have seen a lot of different types of software, mostly are for high performance characteristics. But in the first place, why are you interested in writing a book about software mistakes and trade-offs? This is quite interesting because I don't see much of such book, except, some anti-patterns, maybe there is. But in the first place, software mistakes and trade-offs. Why do you want to publish this kind of book?
Yeah, so from the beginning of my career, I've started noticing that software engineering involves a lot of decisions, and the decision has some trade-offs. So we have pros and cons and so on. It's not like one decision is always better than the other, but of course you can have more than two options and possibilities. When I was involved in this variety of systems, in some business, strictly e-commerce systems, big data, streaming processing and so on, the team tackled a lot of those decisions and trade-offs at different levels. So there were decisions at the low level, like code patterns, that's every software engineer needs to make them almost every day, but also more architecture decisions that you can like discuss with your team each sprint or each 2 weeks, or even more high-level decisions that will influence your evolution of your software, its maintenance, flexibility, also performance. During those breaking points in my career, when we choose one solution over another, I've started to writing a personal list of those decisions and how they end up, like from the time perspective. For example, how this decision impacted our software after 1 year, after 2 years, and so on. Because also I had the pleasure to work with those systems, not only during the development, but also maintenance and when the system was deployed to production and I saw actual usage of it. After that, I've created this list of decisions. It was like 15 of them that were really important. And after some time, I saw that those forums are quite generic. So I decided to share it with other engineers, architects, and so on. So they will not make the same mistakes and they will be aware of those trade-offs, because sometimes you are not aware about trade-off at the decision time, but later, like after a year or two, this is costly. So maybe this cost could be alleviated after you will read one of my chapters of my book.
So as a software developers, I know that a lot of times as a developers, we tend to work based on just business requirements and, just ensuring that the functional correctness, the input produces the correct output. So in your opinion, right, what should be the attitude of developers or software engineers in terms of looking at possible software mistakes and trade-offs? Is it something that they have to be aware since the beginning before they even write the software? Or is it like during the implementation? Or like how should you advise for software developers to relook at all these potential software mistakes and trade-offs?
Yes, I think there are two different approaches to that. So first one is when you are picking some framework or library that will shape your code base and influence your code base a lot. So for example, in the JVM world, if you are picking Spring framework, it will influence your code base and will be hard to change it to something else in the future. Also, for example, if you are picking a queue solution and you are picking Kafka, you need to be aware about these trade-offs. It is favoring availability over consistency, depending on the settings of acknowledgements. With every distributed system that you are integrating with, you need to ask the same questions, like how to influence consistency, availability, and so on. So for those situations, I think it's better to try those upfront. It is possible to know them upfront by doing good research and prototyping. On the other hand, there are those low-level decisions like refactoring of the code and picking a specific pattern or design. In this situation, maybe it's better just to experiment with the code and compare like two approaches, right? So maybe it's not so costly to, for example, implement a solution using inheritance, but also implement another solution using composition. It can be even implemented by two engineers, and then you can compare your solutions and pick the better one. So basically in this second scenario, the cost of experimentation is lower. So maybe you can postpone the decision about which one you will choose. And in the first one, the cost is higher because once you have this in your application, it's really hard to migrate. So it's better to read about it, educate about it, and know those trade-offs upfront.